Right now. Okay, recording has started. Hello everyone. Welcome to the introduction to machine learning for EV3 with Scratch 3 2 camp. We will be focusing on real-time video image applications using machine learning. If you are taking this for the first time, it's fine because using Scratch is so easy and simple and very intuitive, so you can catch up, you can follow. Also, I'm focusing on only video imaging applications, so it's fine for new students to attend this camp without the previous ones. As I mentioned, this file can be accessed at this link. Also, I put this link on the chat, so you can directly click on the file through the Zoom chat, and recorded lecture video will be available after the camp. My name is CJ Chung, Professor of Computer Science, the founder and director of Robofest at Lawrence Tech University. I'm happy to meet everyone. How many are there now? We have 25 people attending now. And I know some are from India, Philippines, Saudi Arabia, and Russia. So actually this camp is international. And thank you so much for joining this camp. Okay, so Robofest camp is about combining workshop together with mini project competition. So from the first camp, there were two winners. One developed smart mask detector using Lego robot. Another one developed smart sharper. And second camp winners are listed there, recognizing handwriting to turn off, turn on a fan. Also, mood recognition, recognizing
，Chris 加入那个什么了没有？
sanitize
那
and
个
sanitized.
上那个 camp 了啊？上去了 ，OK， 行，我就那什么，sure， 好嘞。
So,
行，好。
at the end of camp, I talk about your opportunity to participate in a small mini project competition. Top teams will win prizes sponsored by our sponsor, Denso. Okay, this is the Zoom class rules. Please mute your microphone. We have over 30 people joining this lecture. When you have questions or when you want to answer my questions, use Zoom chat. Okay, so use text Zoom and keep monitoring your chat. So please use Zoom chat. However, it is also okay to unmute and ask questions anytime. That's also fine. Okay, so we are here to learn about machine learning. In machine learning, machines are taught to learn from example data. So, yeah, I'll show you an example, a machine learning example. Okay, so we present some examples to the machine learning system. So this is the first example. 2, 3, 4 are given. And the right answer is 4. So we teach the machine. Okay, if you are presented with an example like 2, 3, 4, then the correct answer is 4. And we teach the machine. Then second example, 3, 5, 9, then the answer is 2. 6, 3, 4, then answer is 3. 4, 3, 8, the answer is 0. So far we presented 4 examples. And perhaps some of you can find the hidden logic why we get those numbers. Okay, another example. 3, 4, 1. The answer is 3. 2, 8, 9. The answer is 4. 7, 3, 1. The answer is 1. So, we teach 1, 2, 3, 4, 5, 6, 7 examples, with 7 examples to learn some concepts. After the teaching the machine, we ask the computer, when you are given 3, 5, 4, what will be the answer? So we are better than computers in many cases. Can someone guess the answer? When you are given 3, 5, 4, what will be the answer? Can someone chat the answer? So you need to find a hidden rule. Why you get 4 when you are given 2, 3, 4? Why 2 is the answer when you are given 3, 5, 9? Can someone guess? So a hint, add all the numbers together, then do some operation. So if you add 2, 3, 4, it becomes 9. Then the answer is 4. How? What kind of mathematical operation is needed to get 4?
2?
Guess.
Okay, someone said 2. Why? Very clever.
Because if you add them all, like the digits up.
No, but what about this one? So if you add all of them, you get 8. Okay.
Then what?
Oh, add and divide it by 5.
Yeah, divided by 5. I heard that. Yeah. Then what?
Add all of them. What do you get? 9.
Yeah.
Divide by 5. What is it?
So for example, why we get that? We add all the digits, then divide by 5 and take the remainder. That's the answer. Okay. For example, this one. So this becomes 15. 15 divided by 5, is 3, but no remainder, so 0. So the question was 3, 5, 4. So 12 divided by 5, then the remainder is 2. That's why 2. So actually, we are clever. So we found out a kind of hidden logic, hidden rule, in these examples. But computers can do the same if you provide a nice machine learning algorithm. So this is an example. Okay. So this is a concept of machine learning. So on a computer, we have a mathematical model. So, we say this model as, deep learning or, machine learning algorithms on a computer. Then, you present examples, like 7 examples with correct answers. Then the nice algorithm on the computer can understand the hidden logic behind these examples. So now, by presenting those sample data, the computer can be trained. After the training, we present unseen data before 3, 5, 4, then well-trained machine learning computer can answer the correct one. So that's the concept of machine learning. So that's what we'll be doing. In this class, we are not developing, the algorithms, machine learning algorithms on this computer, but we are trying to use pre-developed, machine learning algorithms today in Scratch to solve some real-world problems. Okay, another view. Actually, this is the view of the system we'll be using today. So we have 5 buckets. Why 5 buckets? If you divide a number by, by 5, then remainder to be only 5 cases, 0, 1, 2, 3, 4. So this is the bucket when you get 0 as the result, as an answer. For example, 4, 3, 8, if you add them all, becomes 15 divided by 5, then no remainder. So this belongs to, this belongs to the group label 0. And this one, 11, so remainder is 1, so this is another group. And so 6, 3, 4 will give you 3, that's the answer. 8, 4, 1, 8 gives also 3. So this example belongs to this bucket. 2, 3, 4, 2, 8, 2, 8, 9 also belong to this bucket. So it's like now, so we have 5 buckets with examples belonging to that bucket. Now the question is, now we have unseen data. 3, 5, 4 is given. Which bucket should this sample belong to? So it should be.
ఏం పిల్లలు కూడా అటెండ్ కాలేదు
Someone
ఏమి ఇచ్చాడు ఇక్కడ శ్రీశాంత్
Can everybody mute, please, if you guys are not talking?
Yeah, please. Please unmute.
Hey, JP, make sure that you guys are muted.
Thank you. All right. So actually, same idea. This idea and this idea, same idea. Different view, but this view is the one the system will be using. Okay. Another example, which we'll be experimenting today. So we have 2 buckets, 2 groups. One group contains all the examples of with pictures of person without mask. So this picture of me without wearing a mask. Another group contains all the picture of myself with a mask, right? So we train the machine learning system with 2 groups of examples. After the training, we ask to classify, to recognize whether this unseen image, is a mask image or no mask image. So in this case, I was wearing. Definitely, if well trained, the system will tell, the person is wearing a mask. So this belongs to this group. Okay, so I introduced some examples of machine learning systems, and let's define what the machine learning is. Machine learning, ML, is a subfield of AI, artificial intelligence. And actually, there are many different ways of implementing ML algorithms. One of the most popular algorithms nowadays is brain-inspired deep learning, so DL. Today, we'll not be developing algorithms for ML or DL. We'll be using. So the current system we'll be using is using both traditional algorithms as well as deep learning algorithms. So let's define what the machine learning is. ML is a technique where computers can be trained by using sample data to output answers without being explicitly programmed. You just present sample data with correct answers, keep presenting keep training the system, then the system, machine learning system will, will find out the hidden logic based on the sample data, then can answer, when unseen data is presented to the system. Machine learning algorithms build a mathematical model based on training data in order to make predictions or decisions without being explicitly programmed to do so. Okay, another simple example I explained in previous lectures. So let's assume the numbers are from a light sensor, ambient light sensor. If ambient light is dark, it gives higher number. If if dark, lower number. If bright, higher number. So like number 2, the answer would be D, dark. 3 is low, so D. 9 high, B, bright. 0 low, D. 6 bright, 7 bright, 8 bright. So we teach with these samples. After the training, if you ask whether one is dark or bright, yes, it will say D. And actually, this machine learning model learned about this logic. If the number given is less than 4.25, then the answer is dark. It is automatically learned. In traditional programming, we had to introduce if-then logic, handcrafted logic in your program, but no handcrafted logic like this is necessary if you are using machine learning. Okay, 3 new Scratch extensions to use today. So we'll be using video sensing extension, face detection extension, pose detection extension today. Video sensing extension will be handling, capturing, video images from the webcam. Face detection extension has a pre-trained model on the cloud. So if you, include this extension, it's like you are having a very powerful pre-trained model on the cloud somewhere so that you can freely use. The same thing, if you include post detection, then you have a very powerful, well-trained, trained model on the cloud to find the location of your body, from the picture you captured through the webcam. So yes, we'll be experimenting all 3 today. Okay, so we'll have 3 projects. Projects means I want you to, to do it by yourself. But I'll show you how to do it. I'll demonstrate how to do that. So first project would be face detection. I want you to paint your nose with red color. We are using pre-trained face detection model. Project 2 is about mask, no mask. So I want you to, develop a system to classify whether a picture contains a, person's face image with mask or without mask. We'll be doing 2 different ways. You'll be using images from the web, but the second one would be images from your webcam using your own model and your own Scratch coding. Project number 3, post detection, wrist up or down. You lift your hand, lift down, but your program will be detecting your wrist and decide whether your wrist is up position or down position. So that's what we'll be doing. Okay, we'll be using machine learning for chips.co.uk, developed by IBM UK office there in London. So I believe everyone has the account, and the account is actually paid account because they charge image processing. So I'm paying the account. The account is for free as long as you use. So if you don't use for 30 days, then it may be closed. Your account can have up to 4 projects. Multiple devices can use one account, but projects in the account must be shared. I mean, that means your machine learning projects will be stored in a cloud. So using the same account, you can access the same ML model. So okay, if you don't have the account, please ask Zoom chat now. So I see one email. I don't have one more for the new team. Okay. So okay, then yeah, please wait. So
It's
as I
okay,
mentioned,
CJ.
I'll create and I'll send another account, but it's fine. If you have one, you can first log on. So also first project does not require the account. So I'll be creating the account and send it to you, Jenny Lo, during the break.
Okay.
We plan to have a short break. Yeah,
Okay.
we we have only 2 hours today.
It's okay.
So,
It's okay.
yeah, but again, we can use the existing account. Many can use the same account.
Okay.
All right, thank you. All right, so also, especially if you are new to this camp, then I strongly recommend you to watch this YouTube video to learn more about traditional ML4 kids projects, which are using text data, number data, image data, and sound data. Today, we are focusing on real-time video images. So the video does not contain any of the real-time video images, but the previous video shows about text, number, image, sound classification projects. Okay. So this is a kind of scratch review and a simple face detection demo. So this is not a project. That means you don't need to follow me. Please just watch. Okay, so this is a kind of scratch review, scratch block categories. So motion block, the color is in blue. This with the movement of sprites. So usually when you want to move the sprite to XY location, yes, you use this motion, blocks in this motion block. Looks blocks are related to the appearance of the sprite. Sound blocks control sound. Events blocks to trigger the script. Control blocks on the basic flow of the project. Sensing blocks associated with sprites and state detection conditions. Operators deals with many mathematical functions, logical operations, variables to store and access data. My blocks, to make a custom block to hold another blocks. Images contain costume and backdrop image reporters. Today, this motion, this blue one and this new one, they introduced these image blocks quite new. This like sea green color will be something quite important to use. Also, events block, control blocks, we are always using those. To create variables, we are using the yellow color to create new variables and set the values to the variables and so on. Okay, another review. There are 6 scratch block shapes. Each script must start with this head block. Something like, this is like head. Stack block, this is the command. Boolean blocks. C blocks, like loop structure and if-else condition structure. And this is important. This oval shape report block can hold numbers and strings. When we call the pre-trained model, we are always using this report block, cap block and the script. Only 2 cases. So we are usually not using these cap blocks. Okay, another review about X and Y coordinates in Scratch. So the center point is 0, 0. That point is 240, 0. X 20, 240, Y 0. And X, this point, X0, Y 180, and so on. So if you display, if you create 2 variables like X position, Y position, and make it, if you click check boxes, then those variables will be displayed. And in this case, it will display the position of this scratch cat. So the cat is here. The location of the cat would be something like X2 position is slightly less than 100, so 93. Y position is less than 100, and somewhere here is 78. Okay, yeah. Understand about the 2D coordinate plane in Scratch. Okay, so yeah, I'll demonstrate a simple project. Simple program to show a picture of myself and display the position of my nose. If you see this, my nose is somewhere here. That means definitely X should be negative, minus 13. Y also negative, minus 31. So I'll demonstrate how to create this program. All right, so, okay, so yeah, I'll share my do you see my machine learning window, machine learning for kids window? You need to go. So this program does not require your account because we are using pre-trained model. So go to machine. You just watch machine learning, then type pre-trained. Oops. If you go there, you will see, this page. Then click on Get Started. Then it will be automatically launching Scratch 3 windows. To show the video stream of my face, you need to include video sensing extension. So video sensing extension is included. Also, to detect my nose, you need to include here face detection extension. So I have 2 additional groups of blocks for video sensing and here face detection. I want to show only the video. So, I don't need a scratch cat. So click on this trash can to remove. Then actually you are writing code on this backdrop.
I have a question.
Yes.
the Scratch website doesn't have the extensions.
No.
Like,
Oh, yeah. So that's a good question. Don't use traditional Scratch site. You need to use, so just watch, I'll give you, another URL later. You need to use machine learning for kiss.co.uk / pre-train. So don't worry, just watch, you'll have a chance to practice later. So then you'll see that because, this, in order to, this is traditional Scratch, does not include machine learning modules. That's why you need to use another URL. Okay, so now we included video sensing and face detection extensions. Now let's write the first program. So we are writing code on this backdrop because we removed the Scratch cat. Always start with, this head block, right? This green flag. Then we need to turn on the video camera. So click on video sensing and turn on the video. And I want the video transparency to 0. Okay. Then I need to introduce not repeat with numbers, but a forever loop. Then we need to create, because I want to display the current location of my nose with X and Y data. So I need to create 2 variables. So click on this orange variables, click on make a variable, and just click X. Position of my nose. That's the variable name. Also, let's create Y position of my nose. Yeah, please, turn off your microphone and please, because we are having 33 people now, and I want you to turn off the microphone. Okay, thank you. And here, so if you create 2 variables and if you check, then on the stage you can display the current variable, the value of the X position and Y position of my nose. So here in the forever loop, I need to set not my variable, but the variable you just created, X position of my nose, to the value from the pre-trained model that recognize my nose and return, with the X value of my nose. So to do that, we need this face detection extension modules. So here we can get this one. So what this is saying is, if this is a reporter block, but doing a lot of things. This reporter block is first actually sending the current image to the cloud and ask the cloud pre-trained model detect a nose and send me the X value of the nose. So this is doing a lot. So then so in return, this will get one number. The number will be stored to X position of my nose. So we need to do both X and Y. So I need to duplicate, because similar blocks, so I can right click, duplicate, then put it down. Then I need to change this X to Y. So to change X to Y, this is something, they need to change. The problem is, it's not easy to get the right way to change it. You need to see the, oh yeah, did you see the hand became on, you know, a mouse. Then you can change that to Y. Okay, so also I realized, oh, I need not X coordinate, I need Y coordinate of my nose. So move that to here. Okay, so again, it keep repeating to send the current image to the cloud and asking to return back with the X value of the nose in the picture, Y value of the nose in the picture. Right after getting those, set to your local variable and keep doing. So yes, let's do that. But in order to do that, I need to use my camera. So I need to turn off. So I turn off. Oh,
Hello?
Hello?
okay. Can you hear me now? I think so. Yep.
Yes,
Yeah.
yes.
So, yeah, what I did was I turned off my webcam, and I'll be, you know,
It's less
executing the
glitchy then.
program. So this will take a few seconds because, you know, it needs to start the video.
How do you turn your video off before the start of the project?
There's a button that says turn video off.
Okay. I am having a technical difficulty. I have never tested my program with Zoom. It seems like it has a conflict with Zoom camera. So yeah, I'll be
I have a question.
problem is Zoom camera. I turned off Zoom camera, and it should show my camera, but yeah, I am having slight difficulty. Okay, let's see. Okay, so what I can do, I'll try to restart. Let's see. Then I'll start with, then okay, I need to introduce video sensing. Yeah, now it seems it's working. Turn on the video, then introduce control with forever loop. Then we have two variables need to create. So I just say X to save time, and I create Y to save time, then set my variable as X. Then I need to introduce face detection and here X coordinate of my nose. Then also for the variable, I need to set, so I'll duplicate and I change this to Y. Again, changing this is slightly hard because you need to see the mouse point as, okay, so when you see this mouse as the arrow, then now you can change it to Y, and we don't need X, we need Y, coordinate of my nose. Okay, so actually, and you know, in this case, I forgot to remove the cat. You know, also I need to change this as clear stop. Okay, now it's clear. So you see my face and my nose is here. Then the program tells at this time X position is -108, Y position is like 2 or 3, something like that. If I move my face down there, it should be both negative, negative. If I move my face somewhere here, it should be both positive and positive. And somewhere here, positive and negative. All right, so yeah, this is sample program. Sorry, you know, I didn't know about the conflict between Zoom. I should have turned off the Zoom camera before starting this scratch. So yeah, that's something I learned on the fly. So I feel sorry. I should not. I mean, I should have tested, full dress rehearsal, and I admit I didn't do full dress rehearsal. Okay, so now what I can do is, what we did was I just demonstrate this code, and I don't see the scratch cat because I wrote this code on the backdrop, but the second one I showed was I didn't remove. That's why the scratch cat was shown. But this is important to understand about this code. So again, always you need a head block, turn on the video, set video transparency to 0. Then, you need to use this report block to get the location of nose by calling this one. So you need to understand what this report block is doing. This is sending current image to pre-trained model. Then the model sends back the x coordinate of the nose on the image. Okay, so this simple block, small block is doing a lot. Then the x coordinate value was stored into x variable, local variable, and y position of my nose was stored in y local variable, and it was displayed. Okay, now let's start the project 1. Project 1 is red nose. It's like I want you to draw red nose on your nose, like that. So we are using pre-trained model. So yeah, this is the steps to follow. As I mentioned, you need to include those and those, and to draw the red nose, instead of creating your own sprite, I want you to use existing sprite like strawberry and remove the leaves. Then you can you can flip vertically. Then you can have a strawberry nose. Then use that to write code to draw that. Okay, so I'll go through quickly about that and see how we can do this. Yeah, so I need to open this one. Okay, so first, what I want you to do, I just leave the previous project. The first thing I want you to do is you need to go to machine learning for kids.uk. Then you need to log in using your account. Get started, already registered because you have your user ID and everything. So I already created this one. So yeah, so red nose. Okay, so let's create a new project as, just say red nose, and you are recognizing images. So this is what I want you to do it. Then you have red nose, and
Okay, Dr. Chen.
but in this case,
Hello?
you don't need to train anything. Just create, make, then on Scratch, and you don't have any Scratch yet, so you can just use Scratch as is. You can go this way, or you can come to there directly using machine learning for kids.uk/pretrained. And I want you to create. The first thing I want you to do is get rid of the Scratch cat. Then I want you to create the strawberry, upside down strawberry sprite. So create a sprite. Click on fruits, animals, people, food. Then you can find, okay, let's find strawberry here. So now you have strawberry, but click on costume to get rid of the leaves. So highlight that and then flip vertical. Then this is your nose, and it's too big, so I change the size 50%. Then the strawberry becomes slightly smaller. Then we are writing code on this strawberry sprite. So click on code. Then let's do the same thing. Start with, the first thing should be, you need to add video sensing. You need to add face detection. Then add event. Then you need to turn on the video. Make the transparency as 0. Then introduce forever loop. Exactly the same thing what we did before. Variables create X. To make it simple, just say X. Y, location, we need to store to move the strawberry sprite to the location points by X and Y, defined by X and Y. So do the same thing. But, previously we need to store the location of my nose, XY location of my nose. So set variables. Should be X. Then from face, X coordinate of my nose. Oops, not there. Here. Then duplicate this. Yeah, always is hard. Whenever you become the arrow, then time to click to change Y. Then instead of X, you need to do Y. All right. So it's the same program we just did before. But what I want to do is move this nose to that location defined by X and Y. As I mentioned, to move the current sprite, we are using the blue blocks, motion blocks. If you click on motion blocks, you'll find set X to something. Also set Y to something. Okay. So in that case, we already stored X and Y. We don't need to recall, the cloud model. So we can just here use the variable to put X and Y. Right? Do you see? The strawberry is following my nose. I go up. It takes some time, but it follows me. Okay, and so this is something I want you to practice. And if you finish early, as an optional task, you may resize the, the red nose by introducing here. If you go to here, look, there is set size to %. If you introduce this set size to %, you can proportionally change the size of the red nose. So in order to do that, you need to ask also the pre-trained model. So the pre-trained model can tell you the size of your nose in the picture. So to do that, what we can do would be, but it requires a kind of, coefficient or, a number to multiply. So we'll be using operator log. I was using multiplying 5, and I was using size of nose. This will tell you the size of the nose in the picture, then multiply by 5. Then if I come close to the camera, the size of the strawberry becomes bigger. If I go back, the size becomes smaller. Okay, so this is the first project. I want you to do it. And if you complete, please type, I'm done. And if you see my slide, you'll see all the steps over there. My slide, actually, I didn't use those to display the current values, but certainly you can add those too. Or if you don't add those, then, by the way, this stop sign is to stop the program. If you don't want to add those, you can just try this way. Instead of XY, you can directly put this and that. That's the solution in my slide.
CJ, I think they're having problems
either
with their
works fine.
username.
So, okay, I'm seeing 2 people, 2 teams did. Thank you. So please type if you are done. So sorry, I may need to speed up because I lost some time, because of the Zoom camera problem. Oh, I learned a valuable lesson. To start Scratch first, turn off first the Zoom camera before starting the Scratch video projects. Okay, so yeah, okay, so I just sent a web link for the slide today. So far I covered up to slide 34. So if you try to do project 1, you need to follow slide 105 205, 305, 405, 505. I am resending those slide link today. Okay.
CJ, I think the kids need the username password because they can't. Some of the old ones got locked out.
Okay, I see 5 teams did. Six did. But don't worry too much. I'm recording the video. Also, you have the slide. So if you don't finish it, at this time, it's fine. You can do it later. Also, all the projects I'm doing are not related. So, don't worry too much. If you are behind the schedule, behind the progress, don't worry. 7 days. So I'll wait some more minutes then to the next step. So one thing I noticed was this video application, uses a lot of my CPU time. So I realized, that my computer becomes quite slower when I run the camera. Also, forever loop, we are keep asking, keep sending out messages to the cloud system by sending the current image and getting the result. Usually, the frame rate of video camera is 33. So we are sending, 33 images per second to ask the, pre-trained model to get the values for the location of my nose. So that's why the computer becomes quite slower. Okay, so what I do to be, advancing to the next slide. Okay, it's time for taking a group picture. So please turn on your camera now. Please turn on your camera. And it's fine if you don't want to show your face, that's fine, but it's quite memorable to have this unique workshop. As far as I know, no one did this similar workshop like this. Okay, so thank you for turning on your camera. Let's say ML. 1, 2, 3. ML. Okay, let's do once more. Let's say ML.
ML.
All right, thank you. Okay, let's go to the next slide. Okay, project 2 is about interesting thing. Actually, the idea was from the team from Hong Kong, from the first workshop. They did this actually on July 10th. So project 2A is, mask, no mask. We are getting images from the web and you develop your own ML model, but no coding. So what I'll do would be I'll share what I did at this time, perhaps we may not have. Okay, so I'll stop this. Then I log in again. Okay. Then go to your projects. And I created this project before. So I first demonstrate how, okay, so you have two groups, two buckets, one for mask, the other for no mask. I collected those pictures from the web. So I used Google to search just, mask with, face with mask. And for this one, I chose, like no mask. Then what I did was drag and, so find the picture, then I drag and dropped in this bucket. Okay? So you can do that. Drag, drop, and this system requires at least 10 images. This is quite amazing, actually. In usual machine learning systems, you need a lot of images to do something like this task, but only 10 was quite good. I was very surprised. So after collecting at least 10, then it's time to train. So, it's time to teach the system. So click on Run and Test. I already tested. So if you already tested, so you say, the training started that time and current model status is available. And if you want to retrain, you can delete and retrain. But problem is, don't do that right now. I'll not do that right now because it'll take around 10 to 12 minutes. So I can't do that. Now we can test. So what I'll do would be something like I'll do like Facebook face mask. Then click on images. Then you'll find all the people, wearing, masks. All right. So I'll find one. I was looking for someone. I'll find. I've never tried this because I train the pictures only with all the, others. Now I try to find a picture of a young person. So copy image address, then paste the URL there, then test. Let's see. No, I have never done this before. Oh, okay. So the trained model, as you see, recognize the new picture, unseen image as a mask with 92% confidence. So this is quite good. So what I'm saying is, okay, we use two buckets with images to train the model. After the training, we show unseen image. On the system, I was just showing, enter the URL of the image. Then the trained model, answered the correct label. So that's about project 2A. At this time, I don't think we have enough time to do that. So I want you to first, just understand the concepts. So I did, the picture with this one, also 92% confidence. Without mask, I was using this picture with 92% confidence. So you know, yeah, let's have a short break so that I can send the new account to Jenny Low. And yeah, you know, so it's 10:15. So we are meeting 10:18, right? I may need to extend a few minutes because
Yeah.
I realize we don't have enough time. Okay,
Yeah,
see you
I
in
think
3 minutes, and I send
CJ,
the new account for Jenny Low right now, but I need to create the account first.
okay. There's some more kids. If you go back to the chat box, there's a few more kids who needs them too.
Hello, everyone. I'm back. Let's begin. Okay, let's make sure about screen sharing. Can you see the project 2B?
Yeah.
Yes.
Yeah.
Can someone tell if you are seeing project number 2B, mask, no mask on the screen?
Yeah.
Yes, we are seeing it.
For some reason, usually if I have two screens, active screen had edge with different color, but for some reason it doesn't show today. Okay, thank you. So let's start project number 2B, mask, no mask, by collecting your own data using your own camera and creating your own machine learning model and your own code. The idea is, after creating your machine learning project using your account with two groups, no mask and mask, I want you to use your own webcam to collect data without mask, also collect data with mask. Then train your model. After the training, use your own webcam to get pictures of you to ask the trained model whether I am wearing a mask or not. So here, I'm wearing a mask, so the expected answer should be mask. So that's what we'll be doing. So yeah, those are the steps we'll follow. So you need to first go to there, then log on, add new project, and so on. So I'll show you what I have done. So what I'll do would be, I'll show you this. I just created a new account. I sent the username and account to Jenny Low. So Jenny must have two accounts now. And
Yeah, I got it. Thank you.
Logging in the account that contains the project. So that's about mask, no mask. So, okay. Those are the, actually, I'll change slightly. Instead of using your own program, let's use this web interface to create, new examples. So after you create this project, if you would like to add a picture with no mask, click on this one. I'm afraid of opening, my camera, because in that case, I may have another issues with testing my program with Zoom. So you can do it by clicking this, and you can add more pictures over there. Okay, so you can follow those steps. If you click on, then you'll see something like this. If you want to add, a picture with mask, click on that. If you want to add a picture without mask, click on that. You need at least 10 examples, then train, but it'll take around 10 minutes. After the training completed, click on test with webcam, then it will be showing your own camera to feed to the trained system. Then it will say whether you are wearing the mask or not. So now I want to actually do that using your Scratch code. To do that, you need two extensions, video sensing and Lego Mindstorms. If you want to include Lego Mindstorms, to open the gate, something like that. Oh, by the way, regarding the Lego Mindstorms, yeah, it's official that the Scratch link has a bug. So they are working on that to fix the bug. The bug is if you change, your Bluetooth compulse addresses are changed by, if you're plugging in some other USB devices, then high chance the numbers will be changing. Then the Lego will not be working. So that's the bug, current bug. So they are fixing the Scratch link program. So that's why many of the people had troubles of connecting Lego EV3 to your Scratch. So if you are working, yeah, you may test. If not, don't worry, because that's not your fault. That's the bug. Okay. After doing that, I want you to create this code. So I first explain about this code. Again, we are not using the sprite, so remove. So we are coding on the backdrop, default backdrop. Start your program by turning on the video, set the transparency to 0, introduce for loop, then introduce one if block, then ask, please recognize the current image. How do we send the current image to the cloud? By using this backdrop image, reporter block. On this recognize image machine learning block. If you do that, the meaning of this part is I'm sending the current backdrop image. Please recognize the image, whether the image contains a picture of a person's face with mask or no mask. So I'm asking, tell me whether this picture, the person in this picture, wears a mask or not. If no mask is returned, then to make it simple, I was making a just noisy pop sound. So if you don't wear the mask, you'll keep hearing noise pop sound. If you wear the mask, then the noise will go away. So that's the program I want you to do today for the project 2B. So again, Oh, so I see another email that another person does not have the account. Yeah, so I will create the account and I'll send right now. Yeah, it takes time to create the account, so please wait. I'm so sorry. You can. Yeah, I'll definitely send the account later because I don't have enough time, so it will take at least 3 minutes. So I don't want to waste 3 minutes. All right. Okay. So okay. So yeah, I'm getting many emails that you don't have the account, but I sent one account for each registered team. So yeah, I will send you accounts, and don't worry if you don't have the account right, if you can't practice right now, but that's fine because you have all the information, so you can practice after the workshop. But I promise you to send the account. Okay, so can someone tell me whether someone completed this project? But I need to demonstrate actually my code, so I will be.
Can you wait? Mine is still training.
So I have my pre-written code. For this, project 2B. So always make sure you have the correct model name. So, our current project name is mask no mask 2B. Then I can load pre-written program from my local computer. So my mask no mask 2B. That's the program. Yeah, simple program as I just explained. On the video, set the transparency 0. And this is the most important part. Send backdrop image. This backdrop image report block is under images. Backdrop image, use that one and plugging into this recognition block. So, this keep saying, oh, I didn't wear the mask. That's why, you are hearing keep popping sound. If I wear, it's silent. If I remove, yeah, it's complaining. You didn't wear the mask. Okay, so that's the program, but I was interrupted, when I explain about this important block. So you need to compare whether, the label returned from the pre-trained network is mask or no mask. So that's why you need this operator to compare. So you need that. Then, click on your model name. Then I want to check whether no mask and use this one to move it to there. So recognize the current image given. So we are asking the pre-trained model to recognize whether the image contains mask or not. But you have to supply the current image to find, yes, because we don't have any sprite, only backdrop. Provide the current backdrop image to the model to determine whether mask or no mask. So that's the block. This is the most important part. a lot of things are ongoing here, but we can simplify because we are just using it. But if you use well, you can create fantastic applications. Okay, so can someone Zoom chat whether you are done? Yeah, I need to see at least one person complete this. So anyone done this project 2? Okay, so make sure you must have this one. So this is something. Oh, I see. I think it takes time to train. That's why no one did it. So okay, then while you are waiting for the training, yeah, I can just introduce the next project. Yeah, so image processing requires, if you have 10 images, according to my experience, it takes around 12 minutes. If you have more images, yeah, it'll take more. And actually, they are charging by minute right now when you train. Okay, project number 3. Now I just introduced while you are waiting for your, project to be. Project 3 is about pose detection, wrist up or down. So we are using a pre-trained model to detect twist. So we are using, pose detection pre-trained model. Also, I want you to create your own machine learning model to recognize whether your hand is up or down. Here we are using this yellow dot. Actually, the name of this dot is sun in Scratch. Then how do we, so you did similar one, like, drawing the strawberry at your nose location using the same idea. We draw this sun sprite after getting the location of your right wrist. So your Scratch code gets XY coordinate of your right wrist from the pre-trained model and use the same thing as your nose. Move this sun to the current sprite, move the current sprite yellow circle to that point. That's why if you repeat, if you lift your hand up, yes, it's there. It's there. If you down, it moves down, goes down. So here you need to create your own machine. So we are using both pre-trained model as well as your own machine learning model. Your own machine learning model determines whether your hand is up or down. So that's what we'll be doing. So it's this diagram shows everything what we plan to do. we create a project to recognize numbers. So that's our own project to recognize numbers. But we will be using pre-trained model recognizing your images from your webcam. All right. So you create two buckets, two groups. Each bucket has two values for each example. X value, Y value, X value, Y value. And currently I collected 17 for the up case. I collected 20 for the down case. So using your webcam, lift up your hand, gather samples using your scratch code, then place down your wrist, then collect samples for the down case. After collecting enough numbers for each group, train the model. After the training, using the same camera, show a picture, then train the model will tell whether the current your wrist is down or up. According to this sample, it's down, so it should stay down. That's what we'll be doing. And this is the slide to explain all the steps as well as programs to collect data, and this is the program actually to use the trained models. Okay, so let's go back to the previous one. Okay, anyone completed project 2B? Can you Zoom chat? Oh, okay, I'm so happy. Yeah, at least two groups completed project 2B. I'm so happy. Oh, 3, thank you. So yeah, don't worry, because it takes a lot of time to train. Also, it will take some time to follow. So I strongly encourage you to go through everything what we covered after the camp, actually to do the class project for the competition. All right. So let's continue project 3. It's fine. You can create another project while you are training the previous model. Then you can start project number 3. So so what I'll do to be now, I'll demonstrate project number 3. So let's see. Okay, I demonstrate project number 3. So I created project as list up, down, and I collected those numbers for each group, not by entering manually, but by the program. However, if you want, you may enter manually, like at example, then it's asking to enter the X value for the up case. Up case, it's quite easy. Any X value, we don't care. We only care the Y value. So type any value like 0, but the Y value should be greater than something like 80, greater than 80. So it's 9. This is an example. If X is 0, Y is 89, that means your hand is up. I can add like that. So for the down case, yeah, you may add another one. So the same thing, you don't care X. So let's say a number. Y should be a negative number, big negative number like negative 110. That's an example of down case, right? Then go back to the project. Let's let the machine learn. So we need to train, but I don't, actually the train will be quite quick because, training numbers, is much faster than images. So actually I can delete, and because I added 2 manual nodes, so I can train. It takes a few seconds. Oh, it's already done. So you can test it. Like X is 33, Y is negative 100. Is it up or down? Yeah, definitely, it's definitely down. So I don't care X, so let's say X is 0, Y is 110. Is it up or down? Definitely up. So yeah, we have the model. But, this project 3 is trying to teach you how to collect data automatically, because entering many numbers manually will be quite boring. So that's the purpose of this project 3, to use your own Scratch program to collect data for each group. So what I'll show you is the program. Train, run, and test. So click on make. By the way, using this, you may practice Python too. Also, if you want to create a cell phone app, you can use this MIT App Inventor to create mobile app using the machine learning model you created or pre-trained models. So, but today we are using Scratch 3. But as I mentioned, in the future, many people will be using, block-based programming languages. For example, many automotive companies are creating, embedded software using Simulink, another block-based language to generate C programs. So, learning about block-based languages always good for preparing for the future, because you can improve your productivity a lot using these visual programming languages. Okay, so anyway, let's go to here. Make sure you have the correct project name imported. Then I just import, the program I prepared before, like this one, list up down SP3. By the way, don't forget to save your code to your computer. So yeah, this is a program. Okay, so I have 1, 2, 3, 4 scripts. So this script I was using when a certain character is pressed, do this. So when V key is pressed, turn on the video and do this. But I already turned on the video, that's why it's already turned on, even if I didn't execute. Then this part is to collect data to the bucket for up group, for the up bucket. So I'll go through. So this script will be executing when I press up arrow. So you can select different characters. When I press up arrow key, this will be executed. I repeat 10 times to collect 10 examples, but I just use 2 as a sample because I already have many. Then what you do is the same idea. This report block is sending the current image, asking, give me the location of my right right wrist, X location as well as Y location. Yeah, it's done. Then in the local variable X and Y, you have the location of X and Y. Then set this blue block means move the current sprite. The current sprite is this sun. Move the current sprite to X and Y. Then add X and Y to the group up. Wait 1 second, and to make sure you collected a good data. If you hear one pop sound, that means you collected one data. Okay, so I lift, so my, this sample data collection example, I lift my hand up, then I press up key. Okay, just a minute, I press up key. Yeah, moved one, I hold 2 sound, that means the location of here was stored into the up bucket. So let's see whether 2 are added. So let's go back to here, go back to project, train. Yes, this is the manually entered data, and 2 data points were added. I think that those are valid numbers. It's big positive number. We don't care X. So yes, we collected 2 additional samples for the up. Now let's do the same thing for the down case like that, but I skip that. Then let's use it. So when the green flag is clicked, and train new machine learning model. So as I demonstrated, it takes a few seconds, less than 1 second, because numbers are quite quick to train. Then for every loop, we have 2 local variables X and Y. Get the Y location of my wrist, store the number there. Then move the sun to there. Then ask whether the current picture is classified as up or not. If the current picture is recognized as up like that, then keep playing a noise sound. If you make it down, it will be quiet. So, okay, let's run it by clicking this one or that one. So currently my hand is down, so I don't hear any pop sound, any noise. If I make it up, yeah, it's slightly slow. Okay, yeah, you will hear noise. Yeah, as you see, real-time processing using the cloud system is not so fast. No sound, right? So but in the future, many expect, cloud computing will be more popular. So, so that means we are writing code using, many predefined modules on the cloud and pre-trained modules on the cloud. Okay, so this is about project number 3. And before starting your own project, I recommend you to complete project 1, 2A, 2B, project 3. Then I'm sure you can create something very interesting. Okay, so yes, so at this time I want you to start project 3. and I'll try to create some more account and I'll send one by one. Okay, anyone completed project 3? Please Zoom chat. Project 3 can be done easily because the time to train the model, your own model, takes less than a second. Okay, are you working on the project 3? Can you just type if you are working on the project 3 now? And if you are done, please, thank you. Yep. So if you are done, please type done project 3. But during this time, I have some review questions. Okay, let's see. Okay. I'll first do review questions before introducing the review questions. Question number 1. In general, what will help machines to learn better? A, more examples. B, fewer examples. Can you type? What do you think? Of course, more examples. Yeah. It's like, our learning too. When you study, it'll be better to practice with more examples. Right. Number 2. What's wrong? Something is wrong. So if you, there is a mask and no mask. So data collection was wrong. It's like a human error. You need to, so whenever you collect the sample data set, you need to verify. You need to verify whether the collected data set is correct. If not, then it's like teaching wrong things in class. What's wrong?
There was a mask in the no mask section.
So see those numbers, 98, 9. So that means numbers represent number of samples in that group.
Oh yeah. Like,
there are too many cats. A few dogs. It should be balanced. Unbalanced. Whenever you collect data set, consider balancing. Okay, what types of data can ML4Kids system train and recognize? So first, text, numbers. We did numbers. Images. Yes, we did images. And sound. Those are types ML4Kids system can train and recognize. So the answer should be all of the above. Okay, another question. Which of these is not, actually should be plural. So which of these are not good to use of machine learning? Select 4. Okay, can you use machine learning for sentiment analysis, like recognizing the mood, tone, or emotion in text? Yes. How about B, translating text from one language to another? So machine learning is doing a lot of natural language processing and text analysis. Face recognition, of course. Road lane following for self-driving cars. Yes. Recommending a movie based on films you have watched before. Yes. How about F? Calculating the cost of something in different countries based on exchange rate. No, you don't need to use machine learning to do this. You can do simple formula to convert exchange rate using the exchange rate. So no F, not for ML. How about G? Recognizing if an email is spam. No or yes? Yes. This is one of the typical example of using ML. How about G? Adding big numbers together. Oh no, we can just use plus sign, plus operator. No ML. I, counting the number of times a button is pressed? No, not this one. I mean, you may use ML whether a finger is pressing the button or not, but not counting. How about J, converting Celsius to Fahrenheit in temperature? No, you can use just simple operation, not machine learning. Okay, so correct answer can be, yeah, you said that H, I, J, F. So those are correct answers. Select 4 answers. Okay, another question. The following script detects the location of my nose. Select a closest answer that the code might display in the blue boxes below. What's the answer? Yes, someone said B. Will it be correct? Yeah, it's correct. So my nose is here. X value should be positive. Y value should be negative. So only B. Okay, so okay, any project 3 done? Can you type? Oh, almost. Okay. Oh, yeah. So take your time because it contains lots of steps. So take your time and please, make sure to complete it. If you have any questions after the camp, please ask me. Okay, so what I'll do now is to go back to this slide about camp mini project competition. Okay, based on what you have learned today, create any new project using machine learning techniques you have learned today. I mean, vision-based machine learning project you have learned today. Don't worry about connecting to Lego EV3. So just ML project is fine. But if your Lego EV connection is working, then for example, like if you do similar to mask no mask, then you can operate motor to open the gate or close the gate, for example. So I know if you are involved in Lego EV3 and if you can connect to Lego EV3 through Bluetooth, then it's a simple, just one block task. Then send me a video link and Scratch file by Sunday midnight, time here, Eastern Daylight Time. Then I select 2 teams and send certificates and prizes. To get some ideas for vision related projects. There are not that many Scratch vision projects because this machine learning with face detection, pose detection, they are quite new. So there are not many around. So you can create something new so that others can follow. But the developer of machine learning for kids, developed some sample projects like face finder, emoji mask, laser eyes, semaphores. So go there and find out what the creator of machine learning for kids did. My suggestion, if you don't have any idea, then perhaps you can write a simple Scratch code. I already gave all the code. If you lift up your hand, down, up, down, then you can count the number of ups and downs. So that's my suggestion, simple suggestion based on what you have done today. But I want you to create mini project by this Sunday midnight, EST. Okay. So then I need to talk about post survey for students. So this is for everyone who are attending, every student who are attending now. I want you to go to the post survey link. I'll actually type the link on Zoom chat. Post survey. Yeah, to everyone. I want you to go to the to this Google form link to do a quick post survey. It won't take more than 1 minute. I'm sure about 30, 40 minutes. If you complete this, then keep doing your project. And I have another announcement after this post survey. And I'm reading, about 3 or 4 requests to create the link. I mean the account. Yeah, so I'll do that. I already did 2, but I'll do more, right after this class. So don't close your Zoom chat until you get your, your account information. Are you on the post survey? Please Zoom chat if you did. Oh, so yeah, if you don't know the pin, that's fine. Yeah, so I mean the pin used in pre-test, if you don't remember, or if you didn't do the pre-test, that's fine. Just ignore it. It's not required. The four-digit number you entered, when you did the pre-test, pre-survey. So, oh, it's a required question. Sorry. Yeah, then perhaps just enter anything. I don't check. Just enter any number. Yeah. Any four-digit number, or any number actually. Yeah, random number is fine. Thank you. Okay, so I have additional announcement. As you may know, Robofest is doing the online world championship. And we have a category called Unknown Mission Challenge. Mission tasks are totally unknown until the day of the competition. Since robots are built and coded at the competition, there's not a lot needed to prepare. So that means, if you are interested in, you don't need to practice anything. I mean, just practice something I recommend, using a simple base to drive to an edge, line following, to measure the distance traveled, some calculations. If you can do that, then you are all set to to enter the competition. So middle school, upper elementary school can compete on August 28th. Senior students on Saturday, August 29th. So it's like robotics exam. A few spaces are available. Registration fee is $10. And if you go there, you can find previous year challenges. So I strongly encourage you to take this challenge and have opportunity to learn more in this time. Okay. So I'd like to thank first Dale Lane, who created machine learning for kids, who lives in England. So I'd like to thank Dale. Of course, I'd like to thank everyone for joining today's camp. And as I mentioned, please follow my instruction to complete 3 projects and plan to do the mini project to enter by Sunday midnight Sunday. Also, I'm working on machine learning certification programs. So I'll create sample questions like just you did, something like what you did. I create questions like that. Then you may be certified. Okay. So
CJ, I
again,
have a question.
I'm very thankful to have you in this camp, and stay safe and stay healthy. Of course, stay learning. Goodbye. And I'll be turning on this Zoom. So if you have questions, or if you would like to get the